on chapter 5.7, last week we learned to use synthetic division to find factors and solutions of polynomial expressions. This week we're going to take it just a bit further. Be sure again to copy the notes of each new type of problem and listen to the explanations of what will be required of you to move forward successfully. I get the feeling like some of you don't really listen when I'm talking, you just kind of copy it, but again, the explanation is really what should be going on your paper also, or at least a summary of the explanation of these things so that you understand why we're doing what we're doing, because again, that's typically what's the key part. The examples here, given two factors of the polynomial, find the other two factors. So in this case we have a x to the fourth. Now again, thinking about our planning here, if we have x to the fourth, as soon as we take out a factor it becomes x to the third. As soon as we find a second factor, it becomes x to the second, which means that we then do what we did on our last lesson. So it's not that bad yet, but again, it's still giving you some clues and having you practice the process of finding factors, breaking it down, and then finishing it off. So we know that if x minus 4 is a factor, that the opposite of negative 4 should go in the box, which means 4 should go in the box here. And then I put 1, negative 7, negative 28, 244, and negative 336 out there, and then we do our synthetic division, looking for our remainder to be 0, hopefully this time. Bring down, multiply, add, which is negative 40, negative 160, 244 minus 160 is 84. And 84 times 4 is hopefully 336, which it is. Alright, so again, if we knew that x minus 4 was a factor, we take the opposite of that 4, do synthetic division with it, because that's the rule for synthetic division. We get a remainder of 0, and this is what's left over. Now we could put that back into expression form, but really what's the point if we're going to take out another synthetic division? What I would do instead is take these numbers, copy them down, and then put our next number into the box. Because again, we know that we're going to do synthetic division on them, we just need those numbers to be in a workable place. So again, once we know that 0, I would circle it because that means that 4 works. Again, you'll see why in just a second. And then from there we do this again. So 1 comes down, multiply, add, and there we go. Alright, so now that we have it down to 3 terms, which is what we're looking for, we can put this back into expression form. Remember, that's going to be 3 terms. I took 2 things out, so it'll be x to the third, x to the second, minus x minus 42, which means we're looking for numbers that multiply to be negative 42 and add to be negative 1. Those numbers are 6 and 7. Again, I'm not going through the factoring process because we should already kind of know the factoring process. If it's going to be negative 1, it'd be a negative 7, positive 6. And again, what we learned was whenever it's just a regular x, we can just take these numbers and put them into a parentheses. So our 4 factors, if we were to factor that, would be x minus 4 times x minus 2 times x plus 6 times x minus 7. Now again, if we were in class, I would be glad to work those out in front of you to prove that this ends up being this, but for yourself you can multiply that out and do it. But again, what I am doing here is just basically making sure that you see the process so you can use that process to go. But again, the idea, if we know this factor, we take that number, we do synthetic division to get 0. As long as we get 0, we know we did it right, and we know that that is actually a factor. We then, now this would be x, because remember it's 0, 1, 2, 3, so we don't know how to factor x to the third yet. So we do synthetic division again to get down to x squared. Once we get down to x squared, rewrite it in expression form, factor it, and go. Now if this was not factorable, and you were trying to solve, for example, if this was not factorable, then what you would do is just use the quadratic formula to actually use a, b, and c, plug it into the formula, find your last 2 solutions, and that would be it. So again, what you have now is a lot of power to be able to work your way to the information that you need. Alright, if x equals negative 7 is one solution to the expression, I'm assuming they're going to say find the other solutions, and not they, but me. I think I just stopped typing. So again, here, in this one we had x to the fourth, which means there's 4 numbers that should be coming out, and I gave you 2, which means you just had to find 2, which meant we could factor. In this case, I'm giving you 1, and you have to find 3, which means you obviously have to use synthetic division for 1, so let's get started. Again, that's one solution, so we know -7 is a solution, so we put this into the form -7, -49, 307, -252. Now what you will find out about this process is that it can waste a lot of paper, so you'll want to make sure that you are doing what you are supposed to do, because 98, again, it can get kind of ugly as you start guessing what goes. I think 7 times 49 is 343. That would be 636. I don't know. Yep, and then times 7 gives me 252, which is good. That should be a positive 252. So now we have 1, -14, 49, and -36. And here is where things start to get tougher, and I start to challenge you a little bit, because we can't factor x to the third minus 14x plus 49. I'm sorry, x to the third minus 14x squared plus 49 minus 36, because remember, this was x to the fourth, which means that this would be x to the third. We don't know how to factor that yet, so we have to find another number. The thing is, we don't know what the other solution is, so this is where your hunting begins, which is where I now have to try a value. So I'll try 1 and cross my fingers. 1, 1, -13, -13. Look at that, it actually worked. Interesting. 36. Yeah, it worked. And multiply to be 36 to get 0. Now, that's not supposed to happen, of course. Not for me. I would want it to happen for you, but it doesn't always happen like that, because what if I would have chosen the number 2? Hopefully 2 doesn't work also, but let's ignore that for a moment. So put your brains on pause, put your pencils on pause for a moment, but just look for a second and see what would happen if we picked a number that just did not happen to be lucky, because luck is good in this situation. 2, that would be -12. This would be -24. That would be something around, I think, 25. And this would be 50. And notice that you do not get 0. And so what would happen is, and I'm going to explain to you the values that you will use on this problem whenever you get to it on the computer. I made sure that one of your solutions was between these numbers. So if 1 does not work, try 2, try 3. If those 3 don't work, try -1, try -2, try -3. So again, write that down for yourself, because I'm telling you that one of your solutions that's not on there will be one of these 6 values. Now after that, I can't tell you what's going to happen, but again, I'm giving you one solution, and this is how it's programmed, so you could actually get used to the process. I'm giving you one solution, and then your second solution is going to be from this range of values. So try all. If you try all 6 of these and it doesn't work, you need to let me know. But again, it should be between -3 and +3, and 0 is not included, because of course 0 as a factor is not really going to happen. But again, between -3 and 3 is what you should check. And luckily, again, what we found out was that 1 worked. And because 1 worked, now I can take x squared minus 13x plus 36, looking for numbers and multiply to be 36 and add to be -13. Those numbers are, I believe, 4 and 9. Both of them would be negative, so it would be x minus 4, x minus 9. And in the end, that will be x minus 4 equals 0. Because remember, we want the solutions. So that would be x equals 4 and x equals 9. And so these two would be your other, actually these 3, because remember I would circle it if it works. So your other 3 solutions would be 1, 4, and 9. So again, that's pretty much what you're looking at there. Alright. What you need to understand again is that this is pretty much what you need to be able to do in all of the problems. The only difference is as you move out of this section and as you move past this chapter, it won't just be that your second solutions between these numbers, and they actually get kind of ugly. But as long as you understand the process, to me that's more important. So you understand what you're supposed to do. You use synthetic division until you get a remainder of 0. Once you get a remainder of 0, take these numbers, break them down. Try synthetic division again until you get a remainder of 0. Once you get down to 3 numbers, you then put that into expression form, factor it, and get everything else that you need out of that problem. Alright? So after we've learned to fight our way through problems, we must learn to put everything together and solve on our own from the beginning. So in other words, every single factoring method that we've learned is now back on the table on this lesson. So when it says solve the following quadratic equation, this is what we're looking at. We have to actually solve it, which means we want the solutions. That means we're probably going to have to factor or use synthetic division or whatever it might be. But here's the first thing you need to recognize, and again, this is what should go into your notes. Each one of these has a y on it. I'm not going to write those words, but again, if this is what the key is, then you should write something like all terms have y's. If all terms have y's, remember we can factor off a y. I'm sorry, equals 0 should be in there. And so now this is a factor. This now has 3 terms. And so what we can do is say we're looking for numbers that multiply to be negative 12, add to be negative 4. Those numbers are 2 and 6. Again, that's because I've practiced my factoring. That would be negative. This has to be positive. And again, because that's a regular variable, it ends up being y times y plus 2 times y minus 6 equals 0. That's all the way factored. So now we take all of our factors. Remember the rule of solving by factoring, and set them all equal to 0. This is answered. This is going to be negative 2. This is going to be positive 6 because you simply turned those around. So that would be all the solutions that we are looking for. And yes, this is on your homework, and yes, this is on your test. Be ready for it. So again, that's the general idea there. All right. Solve the equation. The thing you want to write here for yourself is that in order to solve this, you need to make sure it's equal to 0. Remember that if there's a x squared or anything higher than x squared, it's like what I call the elephant on the boat, so everything needs to come over. Remember that when you move this 16, you're using its opposite, so you have to rewrite it as x to the 4th minus 17x squared plus 16 equals 0. Now, you could use synthetic division to start, but here's what I want you to notice. And again, this is where everything's coming together, so that's why I'm having this stuff kind of put in front of you so you can move from there. What you should notice is that this x is 3 terms first off, which is good for us, and that this is half of that. And because of that, it means that we can now still factor the way that we possibly do if it works. Let's see, if we look for numbers that multiply to be 16 and add to be negative 17, those numbers are 1 and 16, both negative, and here's what we do. Before, when we had a regular y in the middle, because remember, y to the 1 and 1 is half of 2, when there is a regular y, we put a y in both of these. When your middle term is an x squared, we are going to put a x squared in the middle of both of these. And again, because it's a regular x to start, we can just take that number and put it there. We will then do x squared minus 1 equals 0 and x squared minus 16 equals 0. And remember that there's a couple things you could do. You could factor this, or you could use algebra. Either one of those two things work. If x squared equals 1 and you square root both sides, remember it's plus or minus 1. Same thing here, add 16. If x squared equals 16, we square root both sides, it'll be plus or minus 4. So your 4 answers that you need to type in are 1, negative 1, 4, and negative 4. Now I'm going to pause here for a moment because I need you to understand that this still works even if I had x to the 3rd. Now you may not be able to work it out, but if I had x to the 6th minus 17x to the 3rd plus 16, I would still use those numbers. The difference is instead of x squared on the inside, because that's the x to the 3rd, it would be x to the 3rd minus 1 and x to the 3rd minus 16, because again, 16 times 1 would be your 16. That would be 16x to the third. That would be 1x to the third, which is 17x to the third. And then x to the third times x to the third is x to the sixth, like what we want it to be. All right. So that is the general idea. Our last step forward is going to pertain to imaginary conjugates. The following problem again will be on your work today as well as on your assessment. So write a polynomial with zeros of 6 and 2 plus 6i. With that said, here we go. We know that 6 is a 0, so we should have x minus 6 in parentheses. We know that 2 plus 6i is a 0, so we should have x minus 2 plus 6i in parentheses. But remember, if 1 is imaginary, then you need its conjugate also, so that means that x minus 2 minus 6i is also a conjugate, and that is where we need to see. I will ignore this for now because we need to work with the ones that we're used to working with, hopefully you practice that well enough. And again, what ends up happening is x minus 2 minus 6i, x minus 2 plus 6i. Group them together. I'll just do that on paper. And what we end up with is difference of squares, remember, so x squared, 2 and 2 make 4, x, 2 times 2 make a positive 4, and then this times that is minus 36i squared. Remember that negative 36i squared is the same thing as positive 36, which means that these two things go together to make x squared minus 4x plus 40. Again, doing a couple things here to save myself a little time. Once I know that I squared simply changes the sign because it's negative 1, there's that. Put this together with your 4 to make 40. Now we'll bring the x minus 6 back into play and do our last multiplication. X times x squared, x times 4x, x times 40. This and this make negative 6x squared, so I'll line them up. Plus 24x minus 240. And then putting everything together, you get x to the third minus 10x squared plus 64x minus 240 would be your polynomial. And if you were to solve that, you would find out that all those numbers work as solutions. So as usual, be sure to ask when you have an issue, but again, be ready to show me what you've done so far. If you haven't attempted a problem, then you need to revisit the video for a walkthrough. That it would be my first step anyway. So again, whenever I get an email and someone says, how do I do this? Typically, the first thing that they want me to do is reteach it, which is on the video. So at least watch the video, because remember, you can go back and watch the video, but at least watch the video with the problem in front of you and kind of use my steps as hints for your steps, and then send me a picture of that, and I can say, well, that was close, but you forgot this or that. Again, in terms of email and fixing your problem, I need you to at least try it. It's okay to mess up. That's what we're there to do. But again, the first thing I usually do whenever somebody sends me an email with nothing on it and it says I don't get it, I pretty much have to now teach you the way I taught you on the video. So because there's only really one or two ways to get to the answer, and so you have to kind of know that. So again, if you don't understand an example watching a video, it doesn't mean you're just supposed to skim right past it. It means find some time to go back, watch it again, copy it again, and then when you get to the Math XL again, pull the video up and try it out that way. But other than that, like I said, let me know what's going on, and good luck.